Good evening, class. I hope everybody's staying warm, especially in the midst of this winter storm. I'm going to show you how to graph two quadratic functions that we went over in class today. These are the ones that I assigned for you to do at home. So we'll look at number 5 and number 6. Just to make sure you're on the right track, you can check with what you got. The first thing we got to do is we have to find the vertex. So we need to label A, B, and C. Since the vertex is the opposite of B over 2A, we have the x equals the opposite of B, or -2, over 2 times A. And since A is -1, we put a -1 down there. This would leave us with -2 over -2, which reduces to +1. Thus, that is our x coordinate for the vertex. To find our y, we plug it back into the y equals expression. Sorry, I went over into the graph a little bit. I want to emphasize the negative is not being squared, but the x is. So it's negative and the 1 is squared. So that leaves us with the negative sign remaining. 1 squared is 1, plus 2, minus 3. When you do all that, you end up getting a +1 minus 3, which is a -2. So our vertex is at 1, -2. The key thing to remember here is when plugging in to find y, we had to keep that negative because the negative's actually not squared. How do we find 2 additional points? Well, we're going to go ahead and erase this, and we're going to plug in 2 x values to the right of our vertex. Those x values could be 2 and 3. So if we pick x equals 2, we go ahead and plug that in. We have negative out front, and 2 is being squared, not the negative, plus 2 times 2, minus 3. The negative stays. 2 squared is 4, plus 2 times 2 is 4, minus 3. The 4's can cancel, leaving us with -3. So our point would be 2, -3. You may think you're wrong here, but you're not. Actually, what's going on here is we have a negative slope. So we're going to have a frowny face instead of a smiley face. And we know our quadratic's going to have this general shape. And I hope that helps out. We are going to plug in 3 as our last point. So go ahead and plug in 3. X equals 3. What does y have to be? We keep our negative, we plug in 3 in parentheses and we square it, plus 2 times 3, minus 3. So we get a -9 plus 6 minus 3. A -9 plus 6 is a -3, and we subtract another 3, so we get a -6. Therefore, y equals -6. And our coordinate is 3, -6. So we go to the 3, and we go down to the -6 and put a dot. The last part is my favorite because we can connect the line. And then we reflect. A lot of you drew your axis of symmetry in the beginning. It's the line that's down the vertex. I kind of forgot to draw mine, but now that'll help you out. Since we went 2 spaces to the right of the line of symmetry, we got to go 2 places to the left. And since down here we went 2 spaces, actually it is 2 spaces down here away, and up here it's actually 1, even though it looks like 2. So since we went 2 away to the right here, we actually need to go 2 away this way. And you don't have to draw that in. That just kind of helps me count across the axis. It should form a mirror image. Look kind of like a frowny face or an umbrella, half of the McDonald's arches, but that's what this quadratic function looks like. Let's do one more that's also going to be negative, and that's number 6. So we'll take a look at that one. All right. You may ask yourself, how do we know it's going to be negative? That's because of the negative that's in front of the A term, and it doesn't matter about the others. We got to find the vertex first, so x equals the opposite of b, or 12, over 2 times a, and a is negative 2. So x is going to equal 12 over negative 4, which is going to be negative 3. And to find our y value, we have to plug negative 3 into our equation. We're going to keep our negative 2. We're going to square our 3. We'll just write it down over the graph, and then later we'll erase it. Have our minus 12 times our negative 3 and our minus 17. Negative 3 squared is positive 9, so we have negative 2 times positive 9. 12 times 3 is 36, and a negative 17. When you end up combining that, you do end up getting a negative 18 plus 36 minus 17. Negative 18 plus 36 is just a positive 18, so we'll go ahead and make that a positive 18. Minus 17, and we'll get 1. So our point, or our vertex, is negative 3, comma 1. We can go ahead up here and put the negative 3, comma 1. Maybe some of you want to draw your axis of symmetry in right away. And then you want to go ahead and pick some values to the right. So let's try x equals negative 2. Once again, to plug that in, you have negative 2. Negative 2 is going to be squared. You have negative 12 times negative 2. And we'll squeeze that negative 17 below. So you have negative 2 times 4 plus 24 minus 17. Negative 8 plus 24 minus 17. Negative 8 plus 24, that would be 16. Minus 17 is negative 1. So our coordinates negative 2, negative 1. I'm sorry I keep having to erase on here, but there's not a whole lot of room. If you go to negative 1, so we try x equals negative 1. We're going to have negative 2 times negative 1 squared minus 12 times negative 1 minus 17. So do the same process. You'll get negative 2 times 1 plus 12 minus 17, which is negative 2 plus 12 minus 17. Negative 2 plus 12 is 10, minus 17 is negative 7. So our coordinate would be negative 1, negative 7. We'll put our little dot right there. We can go ahead and draw our line. Notice it's a frowny face. Now we can reflect it across the line of symmetry and form a perfect mirror image. I believe you'll be ready for class tomorrow when I show you how to graph these using a different method. Hopefully everybody stays warm and is doing great out there. All right, have a good night.